Okay? Now, the first thing is we have to examine, as I was mentioning earlier, we have to examine the data that we've received from some external OLTP or online transaction system. So these are the transactions that came from a source system that the FBI used to collect some crime data. Now these aren't real numbers yet. You'll get a chance to work with real numbers. These are just simulated numbers by fake cities that I put in Alaska. City X and City Y, or City Z. Okay, so from left to right, let me describe what you're seeing here. From the left, this row ID, we'll call this the source ID, or the primary key, let's say, from the source system. So you remember, when you build a transaction system, right, you have a primary key column that you create so that each row of the transaction system is unique, right, in some way. So this would, from the source system, this would be the row ID. All right, now, from left to right, crime data was in this case collected from the state of Alaska. All right, and in the state of Alaska, there was an encounter of crime in this city. We recorded City X in Alaska. In the year 2007, there was a population of this city of 50,000 people. In that population, there were 20 violent crimes that were recorded. There were 17 murders, 3 rapes, 5 thefts, and 4 arson. Okay? And City Z within Alaska, same thing, 2007, population 4,000. There were 2 violent crimes, 2 murders, 0 rapes, 3 theft, and 1 arson. Okay? So we're going to examine this first. Now, from this information here, we have to identify what facts or measures that there are. Now, looking at this data here, can anybody identify a column that would be measurable in nature? Anybody just call it out?
Population.
Population. Now, population is a measurable column because it's an example of data which can be measured by some form of an aggregate. Like, for instance, if we wanted to tell, we wanted to add all of the populations or look at which population, which was the highest population that had the most violent crimes. So our business questions that we can derive from, we can ask specifically, we can measure from data like something like population, violent crime, murder, rape, theft, and arson. Okay, so these effectively become facts. So over here we would list, we said that population, that's 1. 2 we said was violent crime. 3 we said was murder. 4 rape. 5 we said is theft. And 6 we said is arson. Okay, so here we've identified easily right off the bat, we just went for the easy target. We'll come back to the year here in just a moment. And to the rest. Now, of what's left over, so what we have left over is year, city, and state, and row ID. Now, what's an easy target for a dimension? Year. Okay, we'll come back to year in a minute. Exclude the year. City. Okay, so city is a dimension because it's descriptive data about the facts, the measurable facts. So there were 2 violent crimes in the city Z. So we know here that the city is a dimension. What else? State, obviously that's an easy target. Okay. What about this guy right here, the row ID? Where does he or she fit And what might be its purpose of putting it in our data mart design? Anybody want to take a stab at that?
It is unique.
It is unique. But does it fit in the place of a measure or a dimension? It's kind of iffy, isn't it? Now, if every single row itself has a different unique ID, it doesn't fit in the area of a dimension. It's not descriptive. However, it's best practice. It's best to place the transactional ID inside the table that is going to consume our facts. Now, are we going to add the row ID? Not necessarily, right? I mean, we might ask how many rows are there, but we're not going to add these two numbers together. We're not going to average them. We're not going to sum them. But what purpose might this serve? This might serve as a validation piece, right? Now, so for instance, let's say that in, right here, we put all of these in our fact table, okay? If we are referring to any data as it relates, so someone asks a business question and they say, how many violent crimes were committed in the state of Alaska in 2007? And then we would write a SQL query, we would build a report, we would generate an answer back to the customer who's asking that question. We would give them a number, and then they might come back and they might dispute what you are saying. They might dispute it. They might say, I just don't think that we had 22 violent crimes in, these two cities within Alaska. I just don't believe it. These are peaceful places. I don't remember hearing about any violent crimes. What are you talking about? So if we had to validate and say, well, according to in Alaska, these two cities in Alaska recorded 22 violent crimes. And what we did was we said, okay, we went back to the source and we validated these two row IDs with, the FBI. And we said, hey, FBI, or whomever the crime agency is, we would say, hey, look, we pulled this data from you. There's a dispute on that. Can you confirm these two rows in your system? Is there any issue? Perhaps someone, made an incorrect entry here. We're hearing from the local sheriff's department. We went and validated it. We looked at their crime report for, 2007. And in City X in Alaska, and the local police department only recorded 18 violent crimes. So wait a minute. So let's look at this violent crime for just a moment. What do we notice in this data about the number of violent crime when you examine it with the rest of the data here? What do you notice?
Murder plus rape.
According to this data, okay, the business requirement ends up defining these two guys here as violent crimes. So these are broken out from these. So perhaps if we went back to the source and said, check these two rows, they come back and they say, yes sir, or yes ma'am, we do validate that is correct. Our algorithm classifies these murder and these rape numbers to be violent crimes. But when we go back to the city Z, if we go back to city X here, and they say, well, whoa, wait a minute, we only had 17 violent crimes, then perhaps they're not encapsulating these other descriptive crimes that the FBI considers in their aggregate, and then you could go back to them and say, we understand that you're disputing our data, but the FBI or whatever the authoritative source defines violent crimes to encapsulate these two crimes as an aggregate of this. So what we've done now is we've identified, okay, some intelligence about, how these numbers are being derived. We now have a set of columns that we could identify in our fact table. We now have identified 2 individual dimensions. Okay? What do we do with this guy? That becomes a question. Okay? Now, what we could do is I'm going to expand this model a bit. I'm going to expand the business requirements just a bit about year. Here's what I'm going to say. The customer is interested in, we're interested in the Chinese New Year for all crimes committed in the U.S. between 2006 and 2007. So what we've got is, so this data that comes through, it has 2007 in it, but nowhere is defined this sort of Chinese New Year. Okay? So what we might do here is we're going to classify the year as a dimension, but with an added caveat that what we must do here is we need to expand that dimension to include not only the year, right, but the Chinese New Year as well in that dimension. So here's our breakdown. Here's our breakdown. We have identified 3 dimensions, right? We have 3 dimensions and 1 fact table. All right? So basically, what we've got here is a model that's been scaled down to something like that.